A question we often hear is, what is the difference between a contactor and a motor starter? Now this question is understandable since contactors and starters both control electric motors, and many people sometimes use the two terms interchangeably, which can lead to a little confusion. So let's have a look. The mechanical elements of starters and contactors are identical. Coil, contacts, arc chutes, and both devices typically use a lower control voltage to electromagnetically pull contacts together. So what's the difference? Well, a contactor is simply an electrical switch, similar to a relay, used for switching current on and off in a circuit. Contactors control electric motors without providing overload protection. On the other hand, a motor starter is simply a contactor with the addition of an overload relay. Like contactors, starters switch electrical power through contacts to control electric motors and other loads. Overload relays protect the motor from excessive load by shutting it down to prevent overheating. This excessive load would otherwise be causing damage to the motor windings or other components over time. Contactors and motor starters are available with either NEMA or IEC ratings. We'll get deeper into the differences between NEMA and IEC at another time, but in a nutshell, NEMA-rated devices are typically used in American-manufactured heavy-duty starters and contactors. They're designed with ease of selection and simple maintenance in mind. IEC-rated devices are more internationally used and are designed with a more specific application in mind. It's also worth noting that many manufacturers offer products that are dual-rated in both NEMA and IEC. If you have questions about these or any other products, visit us at ecoonline.com.
And that relay is basically used for dealing with small fractional horsepower compressors like you find in your refrigerators or dehumidifiers and things like that. So if we look at it, it's has a coil. It has terminals that plugs into the compressor prongs on these small compressors, and basically current goes through this and it would generate a magnetic field only during the startup of the compressor during the inrush or high current levels at that point. So this is one type. This is another style, but it's still the same thing. It's a current relay. And that current relay is used to, like I said, start up the compressor on small units. This is a potential relay. It has three basic terminals, terminal 5, terminal 1, and terminal 2. And basically this is used for larger compressors to be able to open up the circuit for the start winding to take it out. And it uses high voltage or induction voltage through the start winding to hold the energize the coil to hold the contacts open while the compressor is running. Once the compressor de-energizes itself, the switch will close inside of this again. So this type of switch is normally closed. It will open when the compressor is operating to keep the start winding from being energized or damaging it. The current relay again is normally open, and it will close once it starts up because it inrush current, and as soon as it gets up to speed it will de-energize again. It does a lot of motion, so that's one of the reasons why we use it on smaller compressors, because it could damage the contacts if high current was going through it on a regular basis. So these are the difference in electromechanical type of relays. This is a solid state type of control, and this control is designed to have a solid state relay which is used to power up the compressor. It has three basic wires. These three wires here, the black, red, and white, is used to go to the common, the run, and the start windings. Then we got the two power coming in, the two extra leads here, which is used to bring power source in. So the solid state has a built-in capacitor, has the solid state relay, but also have a built-in overload in it too. So it's a 3-in-1. This is a nice tool to use because it can save you parts on your truck instead of trying to stock overload, capacitor, and a relay. It's all built into this one solid state unit. There's no moving parts. So it's a pretty neat unit. So that's for small hermetic type compressors.